So we're going to talk about these three concepts: the logs, the metrics, and traces, as well as how they interact, what they lead to this environment, and actually, in a sense, why you need all three of these. Kind of to start with, Chris sort of did this, is when we look back far enough, we find that if you go far enough back into the history of computing and application space, there were no logs, no traces, there were no metrics. We actually had systems that simply took over the machine and ran the entire machine. And in fact, at one point in time, most of the aircraft in the world were tested on a Cray 2 system with 256 bytes of memory, which is at the time the largest system in the world. But there was a concept for finding the problem inside your application, and it's called wolf fencing. It was finally formalized in about 1982 by, you've got to find a wolf in the state of Alaska. How do you do it? Well, you build a fence in the middle of Alaska, you would listen for the wolf to howl, and then you build a fence down half of that part, and you listen for the wolf to howl, and you keep doing this until you spot the wolf. And so that was sort of the starting point for what led to this concept. And what we discovered was that in this wolf fencing model, you would write off little things like, I made it to line 48, but I didn't make it to line 49. And you knew that your problem was somewhere in that neighborhood. And that led to a more formalized structure of what became logs. When we talk about logs, talk about metrics, talk about tracing, even though they are very different things, they all come back to the same roots: what our systems and our applications can tell us about what they are doing at any given moment in time. So logs were the first, and you can consider logs to be a record of the discrete events that happened over a time period here. And logs can fall into categories like plain text, and this is the one you'll see most often, where people simply put a piece of information they think is important to have for that specific functionality for this. The bad side of having plain text log files is it is dependent on the person writing the log to give you the information that you need, this necessary sets of information. At a former company of mine, for instance, we had somebody who thought it was cute and they wrote their log files in Russian, which wasn't very useful for the people trying to figure out what had gone wrong with this program for that. There's also a concept called structured log files that include a JSON format to this. You'll also sometimes hear this as an events stream, which is really what when we talk about other companies and talk about events, they're really talking about semi-structured logs, where the logs include what the information is in JSON as part of the log structure. A couple of nice things about that, it self-describes it, but the headache is that you have to do a whole bunch of additional work up front to make your log files useful. And then binary log files. MySQL writes out bin logs, we have systemd journal logs, there are others. And these are very seldom touched inside of the type of world we live in. They do exist. So think of it this way. Logs are how we determine how state changes inside of our application and inside of our systems here. And the more you get, the slower things tend to go. You don't see a performance increase or stability as you add more log files. There's a company here in the Bay Area who I was talking to them about their log files, and they write off roughly 50 terabytes of log files every hour, which is a massive number of logs to write off here. And as they look at this, when they do this, it takes them that hour to write them off. So metrics are real simple. It's a set of numbers that give you information about a process or an activity that happens inside of here. And it's usually measured over time. So it's a time series model. It aggregates the data together. So again, it can be pulling the data from logs. It can be pulling the data directly from something that's been set up to emit metrics information here. But it's an aggregation, and it's a roll-up of this data, usually in time series with metric name and key value pairs inside of here. This is where we start getting into things like cardinality. The more key value pairs you have, the higher your cardinality comes into play here. The more ways you can slice and dice the data to find out what's going on. But by gosh, it is really efficient. It's fast. It's easily retrieved. It's efficient to set up alerts on here. You can compress the heck out of it here. So it's efficient in storage inside of here. And actually, the more metrics come in, more things tend to stay the same. Not always true, but generally speaking, you don't suffer a performance penalty by bringing more metrics into the picture. Up in the corner here is one of the more traditional metrics that we see, what's called rate error duration, or red metrics, that we see inside of microservices type environments and cloud type environments. This is where we can quickly look and say what the activity of each of the interacting pieces inside of the application space looks like. And so this is something that gets emitted regularly, and people look at this simply as a starting point to determine what their systems are doing. And now it's kind of the new one. So distributed tracing. And distributed tracing is application trace data. It traces the information about a specific set of application operations. Generally, this is also called distributed request tracing. So it's how we track a trace through the application space from beginning to end, the single trip through the system. And during that, we can determine things like how long something took, what had happened. And in modern technologies, cloud designs, microservices designs, we see this through multiple services. And those multiple service hops are called spans. So a way of looking at this is that we have a service. The first service is this trace ID. It has a span ID. If you notice, there's no parent to this. It's the top of the list here. It makes a call to another service. Now that's the trace ID 1 for this service. Its parent ID goes back to service 1, and its span level is 2. And then you can go down and see, as you continue out, each one of these things determines what the parent is, what trace number this is, and what span this is inside of this. These can go on for a lot. There can be literally hundreds of discrete services that happen crossing all these various microservices. In a request, an e-commerce style request, it is not unusual for it to be 50 to 100 services that get crossed just in showing you the screen on something you might be interested in ordering. Not actually buying it, just looking at what you might be interested in buying for this. And in things like air traffic control, it can literally be thousands of simultaneous services that may be 50 or 60 different functionalities that are handling that workload. So again, traces give us the ability to find out what's going on, how our request went through the activity, and how long each piece took. It's usually represented one of two ways. Now, the first one, and the older one of these, is what's called a waterfall trace graph. And a waterfall trace graph laid out for you and showed you what the service call was, what its operation was, where it was going to, and when it can, what the activity result was inside of here. It shows you, for instance, in this one, the API trace, the overall thing took 206 milliseconds. That the HTTP request took 40 of that. Inside of that, the auth and its request took 38 and 37 apiece. So you can see what builds up. This is the first piece that built up this trace. The second piece was looking at the request, again, which went to checkout, and it built up this trace piece. And then you can see that there were two pieces that were fired off from load cart, one which took a very short amount of time, but one that took a longer amount of time as well. So you can start seeing how each of these pieces evolve. And in this particular case, I can actually tell you that it didn't go through, because a 402 error says, basically, I need a payment verified before I can execute inside of that. The other way, which is more useful in many ways, is what's called a services map or service map. And this shows me the routes that my single request took going through the system. So from my API call, for instance, I went to checkout. Checkout went to an authorization aspect. It went to a product that shows me what's happening inside of its buy patterns. It went to a database to see whether I even had the product. It had the payment, moved over to process the cards. It looked at the shipping information, and it sent emails out to the various places to show what was going on. Likewise, at the same point in time, it looked at the catalog to get the catalog sets of information. And for instance, you may be having, I'm going to show you this item, but I'm going to show you another set of items that may be related, or something that's people that bought your first item also looked at. And so you can start seeing that this gives you, again, a single view picture of how a request transmits the system, as well as how long each step of that transaction took. So this gives you a very quick way of looking at the services environment inside of that. You quite often hear this referred to as the three pillars of observability: metrics, traces, and logs. And they break down to, do I have a problem? Where is the problem? And then specifically, what is causing the problem? And honestly, each of these pieces can be treated separately, but by adding these three together is a multiplicative factor. It is much more powerful if you have all three pieces at your control at one point in time. Now, just to make life interesting, logs can yield metrics. You can do what's called metricization of logs to get the metrics information here. Traces can yield metrics. The red metrics that I showed actually come from the trace data and show us the rate error duration inside of here. You need all three inside of this. And if you, once again, look at this, they give you not only the recognition of an issue, but the recognition of the root causes. Now, you'll also hear a lot about things as events. Everything is an event. Nothing exists unless it's recorded. So that's first step. If you didn't record it, it didn't exist. Tree falls in the forest, nobody hears it, make a sound. You don't know this. But these three things actually overlap, and they start overlapping in interesting ways. And so, for instance, if you do logging and you want to roll up specific pieces inside of your, make certain events or make certain numbers inside your logs aggregatable, then you're going from logs to a metrics viewpoint. Similarly, you can go from a tracing to scope out the specific metrics you want out of tracing to get to a metrics viewpoint. You can do the same thing between tracing and logging, that we were able to take very specific trace data and look at very specific log data inside of here. And then if you're really good, you can go into the middle and look at request scope aggregatable events, which gives you all three things in one spot to manage inside of that. And so that very quickly is a quick introduction to what logs, metrics, and traces look like for this. And if you're interested in more, there's actually an e-learning on DevOps, which does go more into each of these categories a little bit. And we'll be bringing out more things, a more in-depth look at distributed tracing, for instance, in the near future.
Yeah, and thanks, Dave. And what I want to add here is just from a use case perspective and the 50,000 foot view. Modern applications are too complex often to even know what log to look at. And without observability, which is the combination of all of these technologies together, you don't even know what log to look at. You don't know where to go to get that level of fidelity because there's too many interconnected components. And so only with traces, spans, and that ease of visibility with metrics can you find out where you go. Once you find out where you go, you may end up at a log, but you need that correlation across services and the spans in order to do that.